There are several known allotropes of oxygen. The most familiar is molecular oxygen, present at significant levels in Earth's atmosphere and also known as dioxygen or triplet oxygen. Another is the highly reactive ozone. Others include atomic oxygen, singlet oxygen, either of two metastable states of molecular oxygen, tetraoxygen, another metastable form, solid oxygen, existing in 6 variously colored phases, of which one is O8 and another one metallic. Atomic oxygen. Atomic oxygen, denoted O or OP, is very reactive, as the single atoms of oxygen tend to quickly bond with nearby molecules. On Earth's surface it does not exist naturally for very long, though in outer space, the presence of plenty of ultraviolet radiation results in a low Earth orbit atmosphere in which 96% of the oxygen occurs in atomic form. Dioxygen. The common allotrope of elemental oxygen on Earth, O2, is generally known as oxygen, but may be called dioxygen or molecular oxygen to distinguish it from the element itself. Elemental oxygen is most commonly encountered in this form, as about 21% of Earth's atmosphere. Dioxygen can occur in metastable states, called singlet oxygen. In contrast, the ground state is known as triplet oxygen. O2 has a bond length of 121 pm and a bond energy of 498 kJ per mole. It is a colorless gas with a boiling point of -183 degrees Celsius. It can be condensed out of air by cooling with liquid nitrogen, which has a boiling point of -196 degrees Celsius. Liquid oxygen is pale blue in color, and is quite markedly paramagnetic. Liquid oxygen contained in a flask suspended by a string is attracted to a magnet. Singlet oxygen is the common name used for the two metastable states of molecular oxygen with higher energy than the ground state. Triplet oxygen. Because of the differences in their electron shells, singlet oxygen has different chemical properties than triplet oxygen, including absorbing and emitting light at different wavelengths. It can be generated in a photosensitized process by energy transfer from dimolecules such as rose bengal, methylene blue or porphyrins, or by chemical processes such as spontaneous decomposition of hydrogen trioxide in water or the reaction of hydrogen peroxide with hypochlorite. Ozone. Triatomic oxygen is a very reactive allotrope of oxygen that is destructive to materials like rubber and fabrics and is also damaging to lung tissue. Traces of it can be detected as a sharp, chlorine-like smell, coming from electric motors, laser printers, and photocopiers. It was named ozone by Christian Friedrich Schobein in 1840, from the Greek words eta omega for smell. Ozone is thermodynamically unstable toward the more common dioxygen form, and is formed by reaction of O2 with atomic oxygen produced by splitting of O2 by UV radiation in the upper atmosphere. Ozone absorbs strongly in the ultraviolet and functions as a shield for the biosphere against the mutagenic and other damaging effects of solar UV radiation. Ozone is formed near the Earth's surface by the photochemical disintegration of nitrogen dioxide from the exhaust of automobiles. Ground-level ozone is an air pollutant that is especially harmful for senior citizens, children, and people with heart and lung conditions such as emphysema, bronchitis, and asthma. The immune system produces ozone as an antimicrobial. Liquid and solid O3 have a deeper blue color than ordinary oxygen and they are unstable and explosive. Ozone is a pale blue gas condensable to a dark blue liquid. It is formed whenever air is subjected to an electrical discharge, and has the characteristic pungent odor of new mown hay, or for those living in urban environments, of subways, the so-called electrical odor. Tetraoxygen. Tetraoxygen had been suspected to exist since the early 1900s, when it was known as oxozone, and was identified in 2001 by a team led by F. Capase at the University of Rome. The molecule O4 was thought to be in one of the phases of solid oxygen later identified as O8. Kakase's team think that O4 probably consists of two dumbbell-like O2 molecules loosely held together by induced dipole dispersion forces. Phases of solid oxygen. There are 6 known distinct phases of solid oxygen. One of them is a dark red O8 cluster. When oxygen is subjected to a pressure of 96 gigapascals, it becomes metallic, in a similar manner as hydrogen, and becomes more similar to the heavier chalcogens, such as tellurium and polonium, both of which show significant metallic character. At very low temperatures, this phase also becomes superconducting.